So this will be a mini project time in a second. First, we'll go through some calculus revision really quick because it'll be really helpful to understand neural networks tomorrow, which is what I'll be covering. So just really quickly put together some slides to talk about the intuition of neural networks and how that relates to calculus as well. So what this is a model that can try to predict the price of a house, right? So our idea is that, what affects how much a house will cost? Well, then you probably need to look at the land area. You probably need to look at how many rooms are there. You probably need to look at different inputs like the location, for example. So what a neural network does is that all it does is that it takes in some input. So this is the size of the house, number of rooms, for example, and then multiplies that by the weight of some certain number. So for example, you might think, okay, every single square foot is worth like $1,000, right? That contributes $1,000 to the house. That means that your weight one will be 1,000. And for example, the more rooms that you have, the house is probably going to be worth more. So the weight might be, like 5,000. And you multiply that, how many rooms with the weight, how many, the area with the weight, and you add them up. And then you get what this is called is a y hat. So when you see y, what that generally notates to is the result. And then when you see x, that generally means all the inputs. And the subscripts just means the number of. So the first input, second input, first weight, second weight. And the hat basically means it's a prediction. So usually we use the normal y as like the real result. For example, you might have a huge data set to train this network. You have a lot of house prices, and you know for each house how many rooms there are and how big the land is, for example. So that one from the real data will usually be called y. We'll go through an example, and this is why it's called a neural network in the first place, by the way, because it really models what is happening in the biological neuron. So for example, this neuron might take inputs from the dendrites, and then remember the axon helix? But it adds everything up and it sums it up here and decides if it's going to propagate like an actual potential or not, right? Similar thing with the model of neural networks, which is you have an input. This one just adds it all up and then it passes along to the next layer. And this is a really cool small model, but it demonstrates both how calculus and how linear algebra is important. Because multiplying matrices, notice how we have to multiply a input with another weight, in some other input with some other weight. Does that look familiar to some operation that we've done so far? What operations does it remind you of in the linear algebra world? Yeah, awesome. Dot product, right? So for example, you can imagine that our three weights, three inputs, we can put them into a vector, x1, x2, x3. And then we can have the weight as another vector, w1, w2, w3. So this firstly shows just how convenient it is to have numbers in these kind of forms. And if you want to calculate y hat, remember how I said y hat is first weight, first input plus second weight times second input, so on and so forth. That is simply x dot w. So y hat is the sum of these three input neurons, right? And then computing the output, simple as that. So on one hand, you can write it like this. This is how you'll be doing in the NumPy, so the implementation's really deep down. And this is what it's going to look like kind of if we were to write it out. So let's talk about how calculus has an impact on this as well. Has anyone seen this symbol before? Yeah, it's a partial. So the reason that this isn't the same as a normal derivative, which is d, this looks like a d, but it's called partial symbol. It basically means it's along a direction. So for example, you know how before, if I have f of x, right, how y changes, it solely depends on the value of x. So we can do a dy dx. We can figure out how much y changes only based on the value of x. But in this function, there's a lot of things that affect what value of y hat our prediction will be. Because weight 1, weight 2, and weight 3 will all have its own influence on what the final prediction is. So that's why we have a partial derivative. What dy dw1 is that we want to figure out how much of an impact does changing w1 have on the overall prediction. So what would this be? what will, just intuitively, if we were to just apply the normal calculus rules, what will dy dw1 be? Any guesses? Yeah, it's just x1, because we only want to figure out what is the impact of changing w1 on our prediction. So we don't even care about x2 or x3 at all. So mathematically, you can think of these as constant terms, right? And w1, I put this crossed out as well because you're basically trying to derive x1, w1 with respect to w1. So notice how this is literally a linear function, and then you just get rid of the constant in front of the linear option, and then you get x. And this is so cool because I think this is where a case where the mathematical definition matches up perfectly with that intuitive understanding. So what question we're asking here is that how does changing w1 have an impact on the overall prediction? So what is the impact of w1? It's literally whatever's getting put in, right? So you imagine that the bigger the x1, so the bigger this input is, the bigger the effect of changing a w1 is. Does that make sense? So for example, oh, okay, that's the answer already. But for example, if you were to do dy dw2, that is like saying, what is the effect of changing our second weight on the overall function? And that just basically is proportional to how big your input x2 is. Okay? And for example, what is dy dx1? What's that trying to say? Yeah, basically what I'm trying to say is that what is the impact when you change your input by a little bit? And how much that matters is just how strongly the weight of the connection is, right? And this is really cool because it is genuinely still a biological model. Because when you do some action a lot, your brain just maps out the path to be stronger connections with each other, right? And that's literally what's happening when you look into neural networks. Some certain connections are just going to be stronger. And the biological analogy of neurons that fire together, wire together, or something like that is exactly what's happening in our neural networks as well. So that's basically it. Or maybe something else that we'll talk about here. So in this example, see how we have a B. Now what this B is it's called a bias term, and it's just something that we found is actually really helpful if we can have one term that doesn't actually have an input, is always on. So notice how no matter how we change x1, w1, x2, w2, there's always going to be a b there, right? So you can imagine b as, we can't just multiply the size of the house by something and the number of rooms by something. Each house has inherent value being a plot of land. So that b is saying that no matter what input you have, there's always a certain, it's like starting entry, basically. And that's how it's really helpful. So based on our 2D model, that's the y equals to mx plus c. That will be the c. So that's what this bias term is. So what is dy db in this case? Not quite 0. Yeah, 1, because you're just differentiating. These are constants. So notice how we want to figure out how does changing the bias term change our house price, right? So these guys don't have any impact on that whatsoever. But the bias term, if you derive that, so d, just the derivation of a variable is just a constant, right? So basically what I'm trying to say is that it will always have a constant impact on your house price because it's not changing dependent on whatever input you have as opposed to other vectors. Yeah. Usually by the network. Yes, it's all parameters that we learn. Good question though. Anything else? Awesome. So we can move on to the fun part now. Oh, actually, one more thing before we get to the fun part. So this is more like reading math notations because, like I said, the point of this course is just to really give you guys a platform to launch off yourself because it's impossible to teach everything in 3 weeks and it will only keep changing. So something like this is just a very important equation to be able to read. So anyone just looking at this want to have a stab at how our equation here gives us a mean square value.
So I would be like the different examples that you have, and then yi by itself is the true value. So
Yeah.
if it's like a yes/no situation, or like it's like a cat classifier, then yi might be is a cat or not a cat, and then y hat I is the prediction that your model made, so whether the model thinks it's a cat or not, and then yeah, like that difference is whether it was an error or not an error, and then squares, and then you sum it over all the different inputs, and then you divide by the number of inputs.
Yeah, that's absolutely perfect. So being able to read this is absolutely the really something that will allow you guys to keep learning forever by yourself. So like Kavindu said, n is a number of data points, right? So basically, you can imagine what's happening is that we have a model, but we don't know how good our model is. And how good our model is depends on how high the loss function is. A loss function, you can imagine the loss as how much we weren't able to predict from our model. So in order for our model to get better, we obviously need a lot of data. And in this case, we have n data points. So the mean part is really easy to understand, right? It's you sum up the total error and divide it by the number of data points to get the mean value. And what this sum is that it goes from the first data point, I equals to 1, to the last data point. And every single time what's happening is that, remember how I said a subscript, that just means the number of, right? So for example, the first, y1 is, will be the real house price. And minus y hat, remember how that is the prediction that our model made? So y minus y hat will give you how far off the model is. And we square that. And so what squaring does is it has two impacts. So we talked about how it is something that makes sure you don't get a negative, because otherwise everything will just cancel out, right? If you go higher by slightly and less by slightly. But also it really punishes pointers further away. So for example, if I have if you're off by 1, right, that means the error that is going to contribute will still be 1. But if you're off by 4, which is a lot more, it goes to 16. If you're off by like 20, it goes to 400. So see how it scales in this way. So it's really trying to punish the data points further away. So tell us more like you're doing a really bad job. You have to like make sure everything is pretty close. So there's obviously a lot of functions that do model loss, but this is the most important one and builds intuition. And after you square that, remember how the summation notation simply sums everything up. Okay, any questions? Yeah. To the power of 4? Yeah, not really. So you obviously has to be multiple of 2, otherwise, but it does not. There's no point. Otherwise, you might be getting the model to overfit by really trying to like avoid far. Yeah. So there's no point. So square is just like a nice balance. It achieves like 2 things. 4 is like going way beyond. So if it's like 1, it's 1. If it's 2, it's gonna be 16, which is just like huge difference. It might be really too sensitive. Good question though. But yeah, this is basically bread and butter. And the next thing is just like kind of a introduction of how we might derive this. So how might we derive this MSE function? So what we want is a d loss over the d of prediction, so y hat. Anyone want to guess what the derivative of this might be? Yeah. So the summation notation is just there, but all it is actually just a bracket. So you can actually just derive it pretending it's not there. So for example, you know how this is a quadratic? We'll drop the 2 down. So it'll be 2 over n. And then yi minus y, so still in there, but then with the chain rule, you have a negative sign in front. Does that make sense? So it's literally exactly the same as what you guys have been doing normally. Okay? And this is kind of like a preview of how the chain rule is important, because there's no such thing as d loss over d hat, y hat. Remember how y hat isn't something that we can modify directly? How can we modify this? So what this is equal to will be the d loss over dy hat, but also the dy hat over the weight functions, right? Which is what we talked about earlier here. Does that make sense? So the chain rule is so powerful because it allows us to basically propagate your error all the way from the very output through the layers of network into the very beginning, which is the x1, x2, and w1, w2s. Okay, so that will hopefully make tomorrow's stuff a bit more easy to understand while it's here. So the last thing is, I think when I went through these multiplying matrices the first time, it didn't really make too much sense because that's the first time we see multiplications. But hopefully it's a bit better now. So again, matrices are just a stack of vectors on top of each other. And let's say we're assigning a certain weight to each of these. So age, sex, they all have their own weight. And to figure out someone's raw score of how much risk they are at for heart disease, for example, we just multiply the x1 with w1 in that case. And you can see that's why w is like a vector like this, and these will be our x's, right? So hopefully this is another intuitive idea of why matrix multiplication is so important. Because dot products not only give us the direction of where it's pointing at, but it is genuinely so fundamental. It is how our matrix, how our neural networks actually work, right? How we go from each layer to the next is just matrix multiplications all the way through. So for example, in this one, remember how the first entry will be the first row and the first column. So dot product of the first row will be all the x values, x1, x2, all the way to xn, and all the weight values all the way down, right? And that will give you the raw score. So sometimes you might see this raw score as logit. Just keep that in mind. Oops. Okay. Okay. Any other questions? Okay, awesome. We can get to the way more fun part now. And it's kind of like a thing on why did we learn coding? Like, why are you guys trying to learn coding in the first place? Do you want to pass around the mic? There's a mic around, and just like maybe say one sentence, like what's the point?
Like a personal experience as to why.
Yeah, just like why? What motivated you to do coding? To learn coding?
I think I just wanted to explore some stuff outside of med, particularly in engineering, and coding is one of the ways that I could do that.
Yeah, awesome. Pass it along. We'll go through like 5 people maybe.
In like a very abstract way, right? So I see coding the same as media creation. So like if you can generate something that you can easily share with others that benefits and does a task, that allows you to solve problems at scale. And media allows you to influence opinions at scale. Coding allows you to do basic problem solving. Medical devices is coding on devices. So coding is very important for problem solving.
Awesome. Can you pass it right to Bruno?
Okay. I find it very interesting, just like how everything can be reduced to like computation.
Yeah.
Like stuff that I didn't expect, like even words. Like I didn't know that you could turn it into like Unicode and then turn it into binary and then
Yeah.
that can be processed with like weights.
Awesome.
Yeah.
Along the
I am obsessed with maths. I was not getting that hit in medicine, and I wanted a different way to find it. And yeah, I guess I had maybe a part insecurity that in med, like we don't really get any practical or like applicable skills outside of medicine. Like put a cannula in, I guess. But yeah, so I thought coding would be one other way to sort of be able to have like use or be able to create stuff outside of just what we've done.
awesome. Last one.
Similar to a sentiment said before, I wanted to try and learn something beyond what I learned in clinical placements. And a lot of my engineering friends did a lot of coding, and they said that's something good and useful for them, so that's why I wanted to learn.
Yeah. I think that's absolutely awesome. So it really just boils down to two things, right? It's curiosity, like trying to learn more and explore what opportunities are out there. And also, we just want to build cool stuff, right? That's why ultimately we're here. And that's what the goal of today's session is. Because how powerful is this thing? Like, we don't learn coding for the sake of coding. Like, there's really no point to learn it for the sake of knowing code. It's not like a language you ever use in real life. It's just a means to make our idea reality. And we live in such a lucky era now that really you don't need to know all that much coding. You can just get ChatGPT to do so much work. And like, I think most of we are started in the pre-ChatGPT era. But if you started coding in the post-ChatGPT era, if you start in the pre-ChatGPT era, like, it is so hard, like going through all the libraries and finding all the functions, noting, like the way that people word their documents are just different every single library to the next. But these days, you can just know what you need to do, what you want to do, and then get ChatGPT to do it. So the most important thing these days is just the idea, right? So that's absolutely an awesome power. And at the end of the day, that's all we're here for. So that's what we're going to be doing today. So I think my experience in coding is mainly curiosity. It started off curiosity, but just along the way, I managed to do like really some cool stuff, and all of them are like, everything here is basically an afternoon or so. So there's nothing that crazy, but it's just kind of, I want to highlight how if you have an idea, you can just like make it up so quickly. So for example, I do tutoring, high school tutoring, and one of the things I need is resources. Do you guys know a website called atar.rocks? No? Yeah, if you do tutoring, you should. It's like literally, this is getting recorded, but actually, yeah, but you can find a lot of textbooks in the exams, right? And then I was like, oh crap, this is so amazing. I want to download all this stuff before someone takes it down. So I basically was like, okay, but I had to click into every single folder, every single year, every single subject, find the exams I want, and then download and then save it something. Like, that's so painful. So I decided to, do some web scraping. Basically, go to that website, go to the directory this is saved to, loop through to navigate all the years and the things I want, and download exams from the companies that I want. So like, for example, Heffernan is good. Insight's alright, but I wouldn't want like TSSM, right? And then rename all this as well with natural language processing by the specific format I wanted. I would just call like, this doesn't even say methods. So I would say like methods 2024 Kilbar exam 1 solution, something like that. And that's just so awesome. Like, that probably saved me, like a couple hours if I was to go through. Like, if I didn't know coding, I probably wouldn't have gone through all that. And on that topic, some ebooks, they display as like images so that you don't download everything as a PDF. I was kind of annoyed by that. So I kind of just went to the website and then had a keyboard that basically there's a right key that turns a page and a screenshot tool that converts a screenshot to a PDF. And I just have a PDF of like textbooks without needing to, have the actual PDF version. I just downloaded it very easy like this. And they're all like super quick. And even something like this is, I connect, basically reading some applications without knowing the names and everything. So connect the Google Forms, display a random location with a number, update the spreadsheet where it's all saved to with scores and notes. And it's just like really helpful things. I thought, wouldn't it be nice to do it this way? And then it just like turns out that way. This is a dumber one. We had like a new lawn, and the new lawns, like, they had to water quite a lot more. You can't just like let it die slightly, because if it doesn't grow into the dirt, it's like all dead. You have to pay a lot of money. So I had a weather API that goes to how much sun is over my house, the corner of my house, how much rainfall is there. I put that all to like a Notion API like this, like a Notion database. And it's a very unprofessional algorithm that determines when to water. For example, if it's like rain yesterday by over like some millimeters, I don't need to water anymore. I can like not water for a couple of days. But if it's being really hot, I'm going to water it tomorrow. And it goes to my to-do list. So the and then through the way, I'll learn API for weather API, Notion API, kind of like how to talk to applications as well. This one is how to work with Google Sheets, Google Form. And it's very simple. Like, other people can just go to my Colab notebook and use this as well. And this one is pretty awesome as well. Like, this is so cool. I got so much resources if you guys want anything. But yeah, it's just through the way I learned about web scraping. And also, side note, like cruises, they always have, I know it's like an old people thing, but it's pretty cool. But they always have like sales 24/7. It's like best sale of the year every single week, an email like that. I'm like, no way. Like, I'm just gonna build something that goes to their website and tracks their prices, and then like find the local minimum, right? But it's just like really cool. Like, all these things, with ChatGPT, it will take like this. Before ChatGPT, this took me a while, to be honest. But But with ChatGPT, I can all do this in probably a couple hours at most, like every single one of them. And this is probably the most recent one, and I think my favorite one. Like, after Met Ball, how many photos do you get? Like, through the official photographer? Does anyone actually go through all the photos to find themselves? You really? So I've never done that, like, in 3 years, right? Like, I just take one of the photos, I'm like, okay, I'm not going to go through, it's 4,000 photos. So I thought, okay, and then my girlfriend was like, wouldn't it be nice if, like, the Google Photos, you can just, like, tap people and just, like, find all the photos of you? And I thought, oh, wouldn't it be nice if there was something like that? I thought, yeah, wouldn't that be nice? I thought, hey, I can do it now, It's like, it's so easy with some Python library. So I'm going to demo this live, but I'll show you, like, later with this photos of other people. But it's actually 100% sensitivity and specificity for every single person except me. There's one person that just keeps coming to. You guys can come see it, and I don't think I look like him, but I don't know. He just every single time, like, it just finds me and him. But everyone else is 100. I think I demoed to Nathan like a while ago. Like, that was like all you, like all the different angles of you, right? It found all of that. Like, I don't know. Maybe I'm copying. Okay, but seriously, like, it works for everyone except for me. But. Okay, but like, this is my images, so I'm happy to show. But this is kind of a good demo of, okay, at this point, I didn't know much like probabilities. I was probably like same as you guys. I knew a little bit from high school, but I didn't really know much about probability. I didn't know MLE. I know a bit of linear algebra. No, not really calculus. I was like very rusty. But this is like a demonstration of how it's actually nice to know things, but it's not essential. So the first thing I did is I got ChatGPT to make me like the structure, but then it was really slow because ChatGPT doesn't think about computation power. Like my little MacBook, it can't process, like, this is 4K images, I'm pretty sure. So it first scales everything down. I first found the library to scale everything down a little. I use a facial recognition library to basically store this input as a vector of 100 dimensions. And by the way, at that point, I didn't know that this is stored as a vector of 100 dimensions. It just somehow has like a variable one is like facial input as a embedding. That's what it's called, face embedding, I think. And for example, it's 100 dimensions. You can just think of it as eye shape, nose size, for example. But obviously more abstract. We can't visualize, but that's essentially the idea, right? Every face is now stored in a vector of a certain size. And then it goes through all the images, the scaled down images, not that scaled down, but scaled down images, and it tries to extract every face, every photo, and it stores that as a vector of size, like a list of size 3. Each item will be someone's face embedding. And then it compares. So for example, now that I have changed all the 4,000 photos to just a bunch of numbers with face values, we can compute each vector with that input face. So for example, if I look to this image, like it's basically the same. And what they're doing is that they're just doing my input face embedding with the embedding that it captured, and it does a subtraction to see how different they are. And then how do you compare sizes of impression? It's just a norm, right? And again, I didn't know that at the time. Like, for example, all I was working on was the high level. So I just know that I have a function. They have a function to compare the face embeddings. I have a sensitivity I can go to. It's like a scale from 0 to 1 of how sensitive I want my model to be. And it actually does capture some quite like funny things that if I reduce the sensitivity or like make it increase. So like the threshold is really, really high. It's very, I think, high sensitivity but low specificity. You'll find a lot of people who are like pretty, like look very similar to you. But so, and then what it does is that this is like the overall summary. But you don't even need to know much of it. So afterwards, I went back to figure out what was going on under the hood, and I thought, oh, that's pretty helpful. So you guys will be able to know what's happening under the hood now, but you really don't need to know. And all this is I think it's like 40 lines of code, and you only need one input photo to like try to match it, and then it does everything. And it's really quick as well, because rather than comparing each photo, the first time I run it takes about 20 minutes to extract all the faces as like numbers, and then afterwards it's instant, basically, like to find out you. And then I produce a scale version back up. So this is what we're about in this afternoon. It's just to work together on an idea to reality. And I know that we probably all have things that you come across like, oh, wouldn't that be nice? But now you can. Right now you have the ability to do it, and especially with ChatGPT. So please use as much of ChatGPT as you want, or Claude. Use it to, you can make it do everything. Like right now, we don't care about how you get it done. I just want a cool project that helps you in daily life or solves a problem in medicine. And please use other people's libraries. Later on, we'll be training your own network, so trying to see how it works under the hood. But right now, there's so much things going on. It's like just on top of my mind, like, something I was thinking of is like a facial recognition thing that can help a blind person read out a name. For example, someone walks in the room, like you can just like have an announcement in the earpiece or something, right? And that's so easy to do with the facial recognition library. That's really the project. Oh yeah, from the embassy. But okay, anyways. Something else I was playing around with is I was seeing like how much stuff is out there for people's pre-trained models, because that's the goal. We're not training our own models. We're just working with other people's things. And it's, again, we're so lucky to live in an era where there's so much pre-made stuff out there that you can make a minimal viable product just like instantly. So for example, after a bit of looking, I found like, I was like, okay, we don't, as doctors, we probably don't want AI to replace radiologists, right? But it'd be nice if you're going through like 100 scans that you need to look through. It'd be nice if there's an algorithm that tells you, oh, this is really hard. We think that this is pneumothorax, something that this needs to be looked at right now, just to prioritize it. And that's actually happening in the real world a little as well. But basically, it can like Torch X-ray Vision is a really nice library that provides pre-trained models. So this is an example usage. You can get your image in a JPEG, and then it can predict very simply using that function, and then gives you how much it thinks everything is. So for example, now using your medical knowledge, you can think, okay, anaphylaxis is whatever. Cardiomegaly, who cares? It's not like urgent, right? But if there's a mass, if there's pneumonia or something, you might want to bump that up on the radiology workflow. And you can even connect this with ChatGPT API, which is something you guys should really play around with as well, because it's pretty easy to get started, and you can like give it a prompt and it will be able to generate you like really cool responses. Oh my god, I was gonna get Deepak to show us one of his projects, but he left for the grant meeting, I think. Okay. I'll do a demo while he's not here. Oh, by the way, this is a code for the face recognition. It's very, very simple. And it's not that, like, I just got it working. I didn't really prettify it, so I'm not, the things that I said, like to comment and explain the code and write it in nice functions. Didn't have it here, but it does work. Maybe I'll clean it up one day. But this is Deepak stuff. So one of the problems he identified is that reading case reports is pretty boring for us medical students, right? It's interesting stuff, but you just zone out and just read it, but not really go through the head. So he thought that, wouldn't it be nice if I can input some case? Hopefully this works. Okay, yeah, so in some case, like a really cool case report, and then it just asks us some questions. So this is what we want to learn from the case. These are the questions you can answer. Yeah, so I think it's a minimal viable product right now, but I think it's really cool. Like, it's a problem that we have, trying to look through cases, but it's really boring. So why don't we read it and force us to understand and have some questions? And by the way, I was saying to him, like, he doesn't know. So React is normally how you build this, what's called front end. So you know how right now we're working terminals, but React is something that is called so basically it's something that's really nice to display to the user. He hasn't done this before. Like, look how clean this looks. If you tell me this is a professional website, I will 100% believe you. Oh no, not sorry. I went to the K. No, it does work. So look at this. Like, how good is this? It's very simple, very nice style. If you told me someone professional made it like over as like a legit working website, I'll believe you. And even like the shadows and the buttons, look how fun that is. And that's all through Claude. Like, he hasn't worked with React before, but made something this cool just using API and other people's stuff. So that's a goal for today. Make something cool that is something that you can be proud of and something that gets you to learn a lot, because that's really how you learn coding. You know how people haven't done ITP, we kind of threw you in the deep end. Like, it's really hard, isn't it, to go through all the slides and exercises and stuff. But that's kind of what the characteristic that we want. That it's really impressive that you guys stuck through with us and still here, because it's just like in real life, you just get something you need to do. Like you have a problem that you want to solve, and you just move mountains, you do anything to just get to it. It does not matter how pretty the code is. Like most people's code, like everyone will be telling you to do nice comments and stuff, but no one does that, right? It's all about getting it working, something that you can read, and it's just there to solve a problem. That's all coding is. Like really, in this day and age, we don't care about using ChatGPT. You might think that's cheating, right? But it's really not. You have to use all the tools in disposal, and you can build really cool stuff and really quickly. Okay, anyone have any questions or ideas they want to share? Okay, so
Sorry.
yeah,
I guess my main question about all of this is like, I struggle to see the connection between like we doing like all this like terminal related stuff, and I feel like exclusively it's in like the Python terminal or like the MATLAB stuff.
yeah.
How do you transition that into like for your desktop type of thing, where you just like, I can interact with the website. Like, how do you do that?
Yeah, like the React stuff, like this stuff. To be honest, I've never actually made anything front end myself. So all my stuff is just like it barely works. Like I just care about it working rather than like looking cool, right? So I've actually, but apparently it's really easy with. So I've had two people do it. Someone else. Do you guys know Aaron? He's in year 2, but he's made something really cool as like an OSCE practicer. So basically, he has a case that he puts in, like just so many cases out there, and then you can interact with it, type in questions, and give you feedback after as well. And then he also said that Claude is basically just powering his whole workflow. Like he really doesn't need to know anything about React. He just needs to know what he wants. He sees what ChatGPT or AI makes him, and then he just iterates on it to make it look pretty. So this is something I was thinking of doing. Like if I had more time, I was gonna make like that'll be my next project actually, to make like a web app for my face recognition thing and like make it available for med schools, for anyone to use. And I think it's no privacy issues because it's only the embeddings I'm working with. I'm not actually storing faces anywhere. Yeah. But yeah, no, seriously, I think if you haven't explored this stuff, then it's a great time to explore and see how easy this is to use. So yeah, please, I'll just reiterate again, use as much large language model as you can, okay? And get it to do most of the work. All you're doing is telling them what you want to happen, and their job is to make it happen. But you have to know the problems. Like for example, my first thing, it didn't really work. I had to realize, this is so slow. I need a way to do this. And to fine tune it myself, going through the face recognition library to see what parameters I can play around with. I think, for example, what ended up happening is that it samples every face 5 times, and then it takes like the average or something. And I was like, okay, would it be give me better results if I sample it more? What's the trade-off there? So basically the idea is to get the AI to do most of the work, and then you just like fine tune and supervise it really. Like you're the manager where your workers are just like laboring away, typing code. Yeah, and this is what Kwa really believes in. So he thinks that the next billion-dollar idea will be a one-person team just using AI. And it's really amazing what you can do with it already. Cool. Any questions? Anyone want to share ideas they already thought about, like burning questions you want to do? Okay, so yeah, go off, make something cool. You guys can work in pairs, probably not more than pairs to be honest, because it gets a bit so without like using Git or something, it's really hard to write on each other's stuff. But you can just seriously do all the Colab notebook. Don't need to download any resources, and yeah, get ChatGPT to help along as well. Okay, cool. In that case, yeah, go and